Hello everyone, so today we'll discuss Schrodinger wave equation, the derivation part. So we all know that Schrodinger wave equation is of two types. The first one is time independent, which is independent of the time, and the second one is time dependent, right? Okay, so we will see the proof of both of them individually, right? So let's start with time independent equation, right? Okay, so let's get started. Let me erase this. So we are going to start with Schrodinger time independent wave equation. Okay, so we all know a general form of the wave function, that is psi is equal to e raised to the power I of kx minus omega t, right? We all know this and I won't discuss much upon it, but in the later videos I shall discuss it. Okay, so for now just know this, that psi is equal to e raised to the power I of kx minus omega t, right? Okay, you can write psi also as psi of x comma t. And note that in this I am dealing with only one dimensional Schrodinger wave equation, right? To make the things simple, right? Later we will discuss in multi-dimensional system also, right? Okay. So notice that you can write psi is equal to e raised to the power I of kx into minus I of omega t, right? You can write it like this. Psi of x comma t is equal to e raised to the power I of kx into e raised to the power negative I omega t, right? You can write it like this. Okay. So you get psi of x into e raised to the power negative I omega t, right? Okay. So this is also a way to represent the psi function or the wave function, right? Okay, but we won't discuss much upon it. Okay. So now let's coming directly to the derivation part. Okay. So note that psi is equal to, it is psi of x comma t, right? It is dependent upon two variables, the space and time, right? Okay. So we know that psi is equal to this quantity. Okay. And we know that the total mechanical energy or the total energy of a system is the sum of the kinetic plus the potential energy, right? Okay. You know that kinetic energy is equal to half mv square, right? You can say it. Okay, you can write it like this, half of m square v square by m, right? You can write it like this. Okay, you get mv whole square by 2m. What is mv? Mv is the momentum, right? So it is equal to p square by 2m, right? Okay, clear till here? Okay, so we get e is equal to p square by 2m plus u, right? You get this stuff. Okay, so note this for some time, right? Okay, so note it and let's see. So basically you got these two equation. E is equal to p square by 2m plus u, right? Okay, now see the wave function. Let's differentiate it with respect to space or one dimension, so I will say with respect to x, right? So del psi by del x, why am I using the del operator, not the d operator? Why? Because it is a two variable dependent, means it is dependent upon two variable, so that is why we are differentiating with respect to one variable, that is x. That is why is equal to I of k into e raised per I of k x minus omega t. Just solve it, you will understand how, right? Okay, differentiate again, you will get again a ik term in the over here, so you get ik whole square, it will become negative of k square, and notice that this is equal to ik of psi, right? Okay, so you get this quantity over here also. Okay, correct? Is it okay? Okay, so you got this expression, right? Okay, so notice that k is equal to simply 2 pi by lambda, right? Okay, and you know that momentum is equal to h upon lambda, right? You know this. Okay, the momentum of the waves, right? Or simply from the de Broglie hypothesis also you can say it, right? Okay, so lambda is equal to h by 2 pi, right? Okay, or simply you can say that lambda is, or simply you can say that p by h is equal to 1 upon lambda, which means 2 pi by lambda is equal to 2 pi p by h. Can you say it? Okay, you got this expression. Okay, so from this, so we know that k is equal to 2 pi by lambda, and we know that momentum is equal to h by lambda. So from this we can say that lambda is equal to h by p. We can simply substitute it over here, and we will get k is equal to 2 pi by lambda, and lambda is h upon p. So you get p by h upon 2 pi, right? You will get it like this. I hope you understand how it came. Basically, 2 pi p by h is equal to p upon h by 2 pi, right? I hope you understand. Okay, so it will come just in the numerator. Okay? And observe that h by 2 pi is equal to h cross or h bar. Okay, so we basically get that 2 pi by lambda is equal to p by h by 2 pi, which is equal to p by h cross or h bar. Okay, so basically the wave vector is equal to p by h bar, right? Okay, so we can substitute this thing over here, and we get del 2 psi by del x square is equal to negative p square by h bar square into psi. So let's keep it as our equation number 1, for instance. Okay, now observe that we have proved that energy is equal to p square by 2m plus u. So from this you can say that you can solve for p square from equation number 1, and you will get p square is equal to negative del 2 psi by del x square into h cross square by psi, right? You will get this. I hope my calculation is correct. Yeah, just substitute it over here, and you get negative del psi by del 2 psi by del x square h bar square by psi into 1 upon 2m plus u. Please check the calculation, is it correct or not? So from this you can multiply by 2m both sides, 2m into psi, you get 2m into psi e is equal to negative del 2 psi by del x square into h cross square by, yeah, that's it, plus 2m psi into u, right? You can bring this stuff to the left side, and you get 2m psi. Just see what I'm doing, minus u. Notice that this term and this term is common both, right? That is why I took common and bring it over here, plus del 2 psi by del x square h cross square is equal to 0, right? I brought everything to the LHS. Okay, what's next? Well, let's see. We get 2m psi by h cross square into e minus u plus del 2 psi by del x square is equal to 0. And this is the time independent Schrodinger wave equation, right? So I will write it over here for the time being. 2m psi by h cross square into e minus u plus del 2 psi by del x square is equal to 0, right? You got this thing. Okay, so what we will do in the next part, let's see. So we proved Schrodinger time independent wave equation, right? Now let's move to the Schrodinger time dependent equation. How it goes, let's see. Okay, time dependent wave equation, right? Okay, so let's see. So in this case what we will get is that we know that psi is as a function of time, right? Okay, e raised to the power I of k x minus omega t, right? You got this thing. Okay, So you get from this psi del psi by del t, right? Okay, again psi is a function of x and t, so that's why I'm using the partial derivative sign. Okay, you get negative I omega into psi. Check it, you will get this only. Okay. Okay, so from this you solve for psi. Psi is equal to negative 1 upon this quantity into del psi by del t, right? You get this thing, and just bring the I to the numerator, or wait, we will see it later. Okay, so substitute it over where you will substitute. Let's see. So you got this thing, right? Okay, so now you get 2m psi upon h cross square into E minus 2m psi by h cross square u plus del 2 psi by del x square is equal to 0, right? You get this thing. Okay, so what you can do is you can use this thing and you will get, so we got that 2m psi upon h cross square into E minus this stuff is equal to 0, right? We got this thing. Okay, so now what's next? Since we know that E is equal to h nu, right, for a wave, right, for a electromagnetic wave you can assume, for a photon or something like that. Okay, which is equal to h into 1 upon t, right? 1 upon time period, right? I should say capital T, right? So you get h into 2 pi upon t by 2 pi. You will get this thing. Okay, what is h by 2 pi? It's again h cross. And what is 2 pi by t? It's omega, right? So you get energy is equal to h cross omega, right? Okay, so now we can do is we can substitute over it here. So now we will substitute this thing over here, right? Okay, let's substitute and let's see what we get. From this you will get 2m psi by h cross square into h cross omega, right? You will get this thing. Okay, and what is psi? Psi is this thing. We will substitute it right over here. U plus del 2 psi by del x square is equal to 0, right? Okay, so you got this, and now from this you will end up getting what was del psi by del t. It was negative I omega into psi, right? Okay, so psi is equal to negative 1 upon I omega. I hope you are understanding what I am saying, right? Okay, so from this you get the you put the substitute the value of psi in this thing only, right? In this expression. Okay, let's see what you get. So you get 2m by h bar h by square into this stuff negative 1 upon I omega into del psi by del t, right? You got this thing. Okay, and from this there was a multiplication term h cross omega, so you got cancel this with this one. Okay, and from this now you get negative 2m psi u by h bar square plus del 2 psi by del x square is equal to 0, right? You get this. Let's erase all this stuff and let's move to the further concept. Well, you get finally over here that you can bring negative 1 upon I to the numerator term. You get negative I and you multiply it by negative 1, you get a positive I. So you get 2m upon 2mi upon h bar omega, and notice omega and omega also got cancelled. Del psi by del t is equal to 2m psi by h cross square into psi minus del 2 psi by del x square. So now you can bring everything to the LHS. You get del psi by del t is equal to, what you will get is this h bar is h bar upon 2mi into this thing 2m psi by h bar square into u minus del 2 psi by del x square, and you can solve this thing, right? It is not that tough, you will be able to do it, right? Let's see. By h del t is equal to this stuff, you get negative I psi or let me simplify this, and this will get cancelled and this will get cancelled. So you get negative I by h bar u into psi, right? I hope I did not make any mistake, right? If there is, please tell me in the comment section. Minus or plus I h bar by 2m into del 2 psi by del x square, and you get the Schrodinger time independent equation. So I hope you understood this thing, that how it is proved, and I hope you understood, right? So please do like, share, subscribe my channel, and thanks a lot for watching. Bye bye, take care.